Hello, my name is Ali Sekman. I'm a professor of computer science at Tennessee State University. In this video lecture, I'm going to talk about control structures in Java programming language. We're going to talk about if selection structure, while and for repetition structures, switch multi-selection structure, and different operators. I hope you enjoy it. Once you understand those concepts in Java, they are equally applicable to other programming languages. Okay, let's get started. This is for COM 3110 Java programming class at Tennessee State University. We are going to focus on control structures today. Let's start with if selection structure. That's the easiest structure. You have an if statement right here, and then you have condition. Condition should be either true or false. That's called a Boolean statement. And you have left and right braces, and then you have a block inside left and right braces. Optionally, you may also have else statement. Again, you have left and right braces, a number of statements in the block. And if the condition is true, only the statements within the if statement block are executed. Otherwise, statements inside the else block are executed. Just to emphasize, condition must be either true or false statement, and you should not forget the parentheses, otherwise you will get a compile error. Let's see our first example. This example is going to also remind you certain concepts that I want to go over with you again. First, if you look at this program, can you first tell me the classes that you see? Remember, the class name starts with capital letters. And by looking at this, I can immediately say that scanner is a class, test is a class, and string is a class, and then system is a class. My question is that scanner is a class located in java.util package. In order to scanner class, I have to import this package. However, string and system are coming from another package called language package, java.lang package. In the previous video, I talked about this. It's the default package and it's automatically imported in every Java program. Therefore, you don't have to explicitly import that package. Let's go line by line. What's happening? When I compile this program using Java-C, test.java, remember, in order to compile, you bring command line interface. It is terminal in Mac operating system, and it is command prompt app in Windows operating system. And then you type Java-C, C stands for compile, Java-C space test.java. If everything is okay, if the syntax is correct, Java is going to compile and generate an intermediate code, which is called test.class. And then you can run it by typing Java command, and then test without any extension. Once you do that, Java is going to look for the entry point to interpret your code. And the entry point is the main method. So the first thing Java is going to look for, do I have a main method? And if I do, I have a main method. Is it defined public, static, void, and then parentheses and a string array? And if I do, then it will go to the first line of the method. And here, when I say scanner, scan is equal to new scanner. New is a keyword that we use to allocate memory space for objects. In this specific example, scan is an object whose type is scanner class, and then we allocate memory space. In other words, scan is going to point somewhere in the memory for which some space is allocated, okay? And don't worry about system.in. We'll talk about it later when we especially have a formal introduction to class and objects. Then it will go to the second line. It will say, enter your age. Here is enter your age. And the cursor will stay right there. Why? Because this is print, not println. Assume that I enter 24 and press return. Well, 24 is an int. And I am trying to capture what the user typed using nextInt method. Well, what is nextInt? How do I know it's a method? Because of the parentheses. And nextInt is a method of scanner class. How do I know that? Because I call nextInt method using object scan an object scan has a type scanner. Therefore, next int must be a method of scanner class. And since 24 is an integer, next int is going to able to read it, and then it's going to store 24, or it's going to assign 24 to the variable age. Age is a variable whose type is int. In this class, int, if you recall, int is a primitive data type, and age is going to have 24. So I'm going to have here age, which is 24. In this class, I'm going to use circle to represent objects, and then either rectangle or square to represent primitive data types. So age is 24. Then next line is an empty space, and I'll go to next one. It's going to check the condition. Age. Is age less than or equal to 18? Is 24 less than or equal to 18? That's not true. So it is going to say this is false. Since it is false, it is going to skip if block, and it's going to go to else, and it's going to execute this line right there. And it will say you can vote. Okay? Now, assume that we run it again. I'm not compiling because I compiled once. I have a runnable program now. I did run it once. I'm going to run it again. This time, it's going to ask, again, enter your age. But instead of 16, assume I enter, instead of 24, I enter 16. Okay? This time, it's going to come here, age is 16. Is 16 less than or equal to 18? This time, that is true. And it will execute what? Inside the if block. And it will say, you cannot vote. It will not execute as block. I hope this is clear. Here is another example. It is the same as previous one. The only difference is that in the previous one, sorry. Okay, let's go to this. In the previous one, I had the left and right braces here, but in this example, I don't have any braces. It is perfectly okay if you have a single statement inside the block. If it is single statement, you don't need left and right braces. This statement will belong to if, and this statement will belong to else. So this will execute just like the previous one. However, if you have multiple statements in the block, in the if or else block, you must use left and right braces. Otherwise, you may it may act the way that you may not expect. Let's see this simple example. Again, I have my scanner object. I say enter your age, enter your age. This time, assume I enter 16. So if I enter 16, age is going to be 16. And then I check the condition. If 16 less than or equal to 18, the condition says this is true. Since it is true, it's going to get inside the block, okay? And it will say, you cannot vote, sorry. And then it's not going to execute the else block, okay? But how about this? Now I did remove left and right braces. Now I have a compile error. Let's see why. Look, when you have no braces, only the first statement belongs to, for example, this line, this statement belongs to if, this statement belongs to else. But this statement right now here is hanging there, okay? This statement here, oops. Sorry. Yeah, this statement right here is the same as it is in the main method, right in this level. In other words, I have if, I have this condition, then I have this block, and then I have another block or another statement like this, and then I have else. And then I have this statement right here. Well, this belongs to if, this belongs to else, but the problem is with this statement, it separates if from else. In other words, this part is okay, but when Java comes to else, it will look for an if statement right before else, but there is no if statement right before else. The if block is this block, and there is another block between else and if, and that will be a problem. So it is not going to compile. Okay, how about this one? This one is this one, there's no compile error because this statement belongs to here. This statement belongs to else. The trick is indentation. Java ignores the indentations. It's not like Python. It's very important. In Python, indents have meanings, but in Java, they don't. So this is equivalent to having this block or this statement right here. So assume that I enter age 16. 16 is less than or equal to 18, and it's going to execute this one. It will say you cannot vote. It will ignore else. Ignoring else means ignoring only the first statement. It will still execute the second one. Congratulations, which does not make sense, right? You cannot vote. Congratulations. Actually, you meant to have this left and right braces. In this case, if you enter 16, 16 less than or equal to 18 is true. So it's going to say you cannot vote. It will not say congratulations because this 2 belongs to the else block. Okay. Well, you don't have to have else statement. As I said, that's optional. And you can have only if. For example, here, enter your age 16. 16 is less than or equal to 18. That's true. It will say you cannot vote. You run it again. This time enter 34. 34 is not less than or equal to 18, so it's not going to execute this if statement. It's not going to do anything in this case. Well, I want you to be careful with the control statement or condition. It must be either true or false. Okay, for example, when I say a equal to 1, this is an assignment operator. For example, if I say a equal 25, I'm assigning 25 to a, okay? But if I say a equal 25, I'm comparing a with 25. The output of this will be either true or false. Either a is equal to 25 or not. But here, there is no true, false kind of output. I'm just assigning 25 to A. So this will be a compile error here because that's not a Boolean statement. So this program will not compile. In fact, you probably meant to have A equal 1, but you did only 1 equal, and that's an assignment. It's going to be an error. In some languages, this may be okay, like in C, but in Java, it is not. Let's talk about while repetition structure. This is pretty simple. While condition is true, execute the statements within the while block. As long as the condition true, keep repeating yourself. That's why it's called repetition structure. Again, condition must be Boolean, true or false, and you must have parentheses here, otherwise you will get a compile error. Let's see our first example. Okay, just to remind you, test is a class, string is a class, okay? And we have our main method defined properly. So if I compile it, it will compile, and when I run it, this will be the output. And let's see why. And it's pretty simple. I is initially 5, as you see right here. I is 5. Okay, and then I'll check the condition. Is 5 less than or equal to 20? The condition is 5 less than or equal to 20. This condition is true, right? Then I will get inside the while loop, and I will execute the first line. When I execute the first line, it's going to print what? 5. Okay, and then I will increase I by 3. I used to be 5. Now I is going to be what? 8. And then I will come back and check the condition again. So the condition is 8 less than or equal to 20. This is also true. So I will get into the while loop again. I will print, obviously I'm going to print 8, and I'm going to increase I by 3. I becomes 11. Then I go back to the beginning. Is 11 less than or equal to 20? That's correct. So I will go inside, execute this line. So that means I will have 11 here, and I will increase I by 3. I becomes 14. Then I go back to the beginning of while loop. This time the condition will be 14 less than or equal to 20. Is this true? Yes. Then I'm going to go and print it, which is 14. Then I will increase I by 1. I becomes 17. Okay, and then I go back. Then the condition becomes 17 less than or equal to 20. This is true. I print 17 and I becomes 20. And last time I will check the condition. I will go back and check the condition. 20 less than or equal to 20. This is true. I'm going to go and print 20 and increase I by 3. I'm going to print 20 and I becomes 23. One more time, I'm going to go back to the beginning. Now the condition becomes 23 less than or equal to 20. Condition is not satisfied, so I'm going to get out of the while loop. So it's going to print 5, 8, 11, 14, 17, and 20. And it is pretty easy. How about this one? Now I have a compile error. You see, I'm trying to compile, and it says an error, parentheses expected, and another error, closing parentheses expected. You see here, this and that. That means it is asking us to put what? Parentheses right there. So don't forget the parentheses. All right, so here is another example. This is pretty simple. This is going to add the numbers from 1 to 5, okay? But let's see how it does that. Okay, so I define two variables. One is count, the other one is sum. Both of them have type int, primitive data type int. Both of them are initialized. Count is initialized to 1, sum is initialized to 0. So I'm gonna go here, put count as 1, and then sum as 0. Just notice that I use boxes because they are primitive data types. Then I go to while loop. It says while count is less than or equal to 5. Okay, so the first condition is what? Is 1 less than or equal to 5. The condition is satisfied, right? Then I will go inside. Sum becomes sum plus count. In other words, sum becomes 0 plus 1. So sum becomes 1. It's not 0 anymore, it is 1. And count becomes count plus 1. So count is not 1 anymore, it is 2, okay? Then I go back to the beginning of while loop. I will check the condition. Now this condition is 2 less than or equal to 5. This is true, right? So sum will be sum plus count. That means 1 plus 2. So sum will be 3. And count will be count plus 1. That means count will be 3. Then I will go back to the beginning of while loop. This time condition is 3 less than or equal to 5. This is still true. I will go and do sum is equal to sum plus count. Sum used to be 3, count is 3, 3 plus 3 is 6. So this becomes 6. And count becomes count plus 1, so it becomes 4 here. And then I go to the beginning of while loop, okay? The condition becomes 4 less than or equal to 5. This is true. I go inside, sum becomes sum plus count. Sum is 6. Count is 4. 4 plus 6 is 10. So sum becomes 10. And I will increase count by 1, and count becomes 5. Then I go back to the beginning of while loop. This time the condition is 5 less than or equal to 5. Still true. I go inside, sum becomes sum plus count. Sum is 10, count is 5, 10 plus 5, 15. So this becomes 15, and then count becomes 6. Then I go back to the beginning of while loop. This condition this time is what? 6 less than or equal to 5. That's not true. That means I'm done. And when I am done, sum is, as you see, 15 right there. And it will say sum is, remember plus sign, this is a string between double quotes, and this is an int 15. First int 15 will be converted to string, and it will be concatenated to this or appended to this. So it will say sum is 15. Okay. If you notice, this is nothing but sum started with 0, then we added 1, then we added 2, 3, 4, 5, which was 15. So it is the sum of numbers from 1 to 5. Okay. Break statement. Break statement is important. When you see a break statement, if you come to break statement, you do not execute the rest of the loop and you get out of the loop. So you break the loop. There's also a statement called continue, and we'll talk about it. It's a little different. So let's see this example. So I start with count equal to 0. Okay. So here we have count 0. Then I have condition count less than or equal to 5. The first condition that I'm going to check is 0 less than or equal to 5. This is correct. The condition is true. So I'm going to get inside. Plus plus means increase count by 1. That's all what you need to know now. Later today, we're going to see it. So count becomes, here it used to be 0, now it is 1. Okay. Then it's going to compare count to 3. Is 1 equivalent to 3? No, it will not get into this, and it's going to print count. So it's going to print 1. Okay, and then it will go back to the beginning of the loop. Okay, now it's going to compare 1 to 5. Is 1 less than or equal to 5? This is true. It's going to get inside and increase count by 1. Count becomes 2. And then checks the condition. Is 2 equivalent to 3? No, it will go and print 2. Then goes to the beginning of the while loop. This time, the condition to check is 2 less than or equal to 5. This is true. So it's going to get into it. Increase count by 1. Count becomes 3. Okay, and then checks the condition. Is 3 equivalent to 3? Yes. Then I will get into the break statement. That means I will not execute this line, and I will get out of the while loop. So on the screen, I will see 1 and 2. Okay? So break statement breaks the loop, the immediate loop. How about continue statements? This is the same, almost the same example, but I replaced break with continue. So I'm going to start from scratch again. So this is a good practice for you to also emphasize certain concepts. So this is 0. Okay. I repeat, just like before, the condition that I check is that is 0 less than or equal to 5. This is true. And then I get inside. I get inside. Count becomes 1. Since 1 is not equal to 3, it's going to print simply 1. Then goes back to while loop. Condition to check is 1 less than or equal to 5. This is true. Since this is true, it is going to get inside, and when it gets inside, count plus plus, that means count will become 2. 2 is not equivalent to 3, skip that and print 2. Then go back to beginning of while loop. This time we are going to compare 2 equal or less than or equal to 5. This is true. I go inside and count becomes 3. Then I go and check the condition here. That condition is true, right? Since that condition is true, I will get inside continue. Continue means skip the rest and go back to the beginning of while loop. So I'm not going to print 3. I'm going to go back right here. And then I will check the condition. 3 less than or equal to 5. This is true. I will get inside and count becomes 5. So, 4. So count becomes 4. 4 is not equal to 3. It will go and print 4. And then it will go back to the beginning. And the condition is going to be 4 less than or equal to 5. This is true. I will get inside. Count becomes 5. 5 is not equal to 3. It will print 5. Then it will go back to the beginning of the while loop. Condition becomes 5 less than or equal to 5. This is true. And then it will skip that and it's going to print. Sorry, it is true. Count will be increased by 1. It becomes 6 and it's going to print 6. Then it goes back. This time condition becomes 6 less than or equal to 5. This is not true. We are done. So what we are going to see is 1, 2, 4, 5, 6. Okay. So that's the difference between break and continue. If you break, you get out of the loop completely. If you say continue, you skip the rest of the loop, but you go back to the beginning of the loop. Okay. For repetition structure, this is similar to while, but in many cases, for seems more handy than compared to while, especially if you are dealing with numbers, and we are going to see why. For, again, you have parentheses, you have initialization portion. Initialization is done only once. And then you check condition. If the condition is true, you go and execute statements within the for block, and you do update, and you go back to condition. In other words, first you start with initialization. Then you check condition. If condition is true, you execute your statements. And then you update, and then you go back to condition. And then you loop this way. Okay? So it's pretty simple. And initialization is done only once, as I said. Condition, and then execute statement, and then update and check condition again. Okay. Here is our first example. This is the same example as we did with while loop. This is going to give us the sum of numbers from 1 to 5. But let's see how it is done with for loop. Very similar. So I'm going to go and have count. And then note that count is not initialized there. Okay. And then I have sum. Sum is initialized to 0. Then I go inside for loop. This is initialization, and it will be done only once. And I'm going to initialize count to 1. Okay. So far, nothing special. Then I will check the condition. Here's the condition. The condition here is 1 less than or equal to 5. This condition is true. That means I'm going to go inside. And it says sum is equal to sum plus count. Sum is equal to 0 plus 1, because sum is 0, count is 1, 0 plus 1. So sum becomes 1. Okay? And then I'm going to do update. Update is count is equal to count plus 1. That means count will be 2 now. Once I did to update, I'm going to go back and check condition. I will not go back to initialization. So I repeat, I initialized, check the condition, execute the statement, I updated, and I come back to the condition. This time condition is true, less than or equal to 5. This condition is obviously true. I get inside. Sum is equal to sum plus count. That means 1 plus 2, which is 3. So sum becomes 3. And then I do update again. Count becomes 2 plus 1, which is 3. And then I come back to condition. And now the condition is what? 3 less than or equal to 5. This is true. And then I come inside. Sum is sum plus count, 3 plus 3, which is what? 6. And then I update the condition. Count becomes what? 4. The condition becomes 4 less than or equal to 5. This is true. And then I get inside. Sum becomes 6 plus 4, which is 10. And then I do update once more, and count becomes 5, obviously. And then I check the condition once more. The condition is 5 less than or equal to 5. This is true. I go inside. Sum becomes sum plus count, 10 plus 5, which is what? 15. And then I check, I do the update, so count becomes 6. And then check the condition again. This time condition is 6 less than or equal to 5, which is not true. I am done. I'll come here. It will say sum is 15. Again, this is the sum of numbers from 1 to what? 5. Arithmetic operators. Arithmetic operators are just standard operators. We have addition, subtraction, multiplication, division with /, and modulus. Modulus is the remainder of your divide. For example, if you divide 21 by 3, there is no remainder. 7 times 3 is 21. If you divide 21, if you do 21 modulus 5, it is 1, because 4 times 5 is 20, and the remainder is what? 1. Okay? So this is basically 21 is equal to 7 times 3 plus 0. The remainder is 0. 21 is equal to 4 times 5 plus 1. That means the remainder is 1. 34 is equal to 3 times 10 plus 4. So the remainder is 4. Okay? You divide 34 by 10. You take the integer division, like it's 3 times, and then you get remainder. Okay, equality and relational operators. As I mentioned in one of those slides, equal is equality operator. It says A is equal to B. Okay? When you say A equal B, you are trying to see if A is equivalent to B. And or exclamation mark equal means if A is not equal to B. This means A is not equal to B. Relational operators, less than, greater than, less than or equal to, greater than or equal to. Okay? These are standard things. For example, here A is less than or equal to B. Precedence, this is important. This is gonna be a little maybe confusing, but first of all operators are associated from left to right, except assignment operator. Okay? What does that mean? For example, when you have A is equal to 25, you start from right and you assign it to left. Okay? For example, if you say A is equal to B equal to C, well, what does that mean? That means first assign C to B, okay, and then assign it to A. So the evaluation is from right to left for assignment, but for any other operator, it is from right to left. And precedence, in other words, the order of operations. You first take care of inside parentheses. And then you take care of multiplicative operators, like operations like multiplication, division, or modulus, from left to right. We start from left to right. And then you take care of addition or subtraction, whichever comes first. Then you take care of relational operations and equality operations, and then assignment. Okay, this is important. First parentheses, then multiplication, division, or modulus, whichever comes first on the left. Then you take care of what? Addition and subtraction. Then relational operations or operators start taking care. Then equality, and then assignment. That's the order. Also, there is something called like plus equal. Plus equal means add 3 to I. For example, when I say I plus equal 3, I is equal to I plus 3. This means I is equal to I minus 3. I is equal to I times 3. I is equal to I divided by 3. I is equal to I modulus 3. That's the shortened way to say certain operations. This is a little tricky. Let's talk about this because let's remember first parentheses, then multiplication, division or modulus, then addition or subtraction, and then relational, then equality, and then assignment, right? So here, let's start. First, I have something called x. X is an integer, which is initialized to 10, okay? So that's all what it is. Then y. Y is Boolean. So y is Boolean. That means it's going to be either true or false. And what are the operations that we have? Equality and relational. Remember equality or assignment, sorry, not equality, assignment operator. Assignment operator comes to last. So before that, you have to take care of the other operations. And in this case, we have less than or equal to. So now, x less than or equal to 20. X is 10. Is 10 less than or equal to 20? This is true, right? So y is going to have true in it, okay? And then when I say print, it's going to print what? True, right there. Sorry about my handwriting. I'm using pencil, but I'm going to get better in time with that. Okay, then the next one. We have assignment, and then we have relational operator, and then we have an arithmetic operator. Arithmetic operations come before relational operators. Remember multiplication, addition, subtraction, then we have relational, right? So first I'm going to take care of this one. What is 20 minus 15, which is 5? First, arithmetic operations taking care. Now, x is 10. Is 10 less than or equal to 5? That's false, right? So, z is going to be false. So, when I print z, it's going to print false. Then, I have an interesting operation here. First of all, h is a Boolean. Look, this is called, we are going to learn today, AND, okay? Ampersand is AND. If you have two statements, and if both of them are Boolean, you can compare them. And I'm going to explain AND soon, but look at this one. X less than or equal to 20 is 10 less than or equal to 20. This is true. How about this? Is x bigger than or equal to 5? Yes, because 10 is bigger than or equal to 5. This is true. True and true is true. If you have two statements, and if you combine them with an AND operation, true and true is true. The composite or compound statement will be true. Therefore, H is true. And then it's going to print true right here. I hope this is clear. Another one. Now, let's start with A, which is an integer, and that is 10. Okay? Now, my question is, assignment will be the last one. I have modulus and then equality. If you remember, arithmetic operations come first. So that means I have to take care of this part first. Okay? So let's do it. And let's use a different color here. What is A modulus 2? That means 10 modulus 2. 10 modulus 2 is 0, right? Because there's no remainder. Then this statement becomes 0 equal 0. Yes, this is true because 0 is equivalent to 0. So this is true. In other words, B will be what? True. So when I print B, it will print what? Let's bring this one here. Then you will see the first one is true because B is true. Okay. Now I want to explain something here, a new concept. Single quote and A. What does that mean? Remember when I explain character data type, I say that, let's use a different color. Character is a primitive data type represented by 16 bits. That means the range is from 0 to 65,750 something, 56 maybe, okay? So that means the range of characters are integers, the range includes integers from 0 to 65,000 something. And for every character, for example, for A, there's an integer number associated with it. I think it's something 16, I'm just making it up. For example, capital Z, there's another number and so on. Every character is associated with an integer number. And for character A, it is not 10 for sure. So here I have assignment operator and equivalent. I'm comparing if they are equivalent operators. So is A, the character value of A, equivalent to 10? That's false. It is not. So this is false. Therefore, X here will be false. So when I print X, it's going to print what? False. Okay. Well, then let's look at this. X is what? False, right? X is false. Now I'm comparing X to false. Is false equivalent to false? So this becomes here false equal false. This is true, right? False is equal to false. This is true. Therefore, I will be what? True. Okay? So when I print I, it will print true. Now the last one. Okay. Character value of A is not equal to 10. That's true. Because character value of A is something else. So therefore, this statement right here is true. And therefore, J is true. And when I print it, it will print true. Okay. Okay, so here is another example for this for loop. Okay, it's pretty simple. Let's use black here. So I do initialization first. Okay, I initialize I to 30. Initialization is done only what? Once. Okay, then I do this and then I check condition. Condition is I bigger than 0. So what does that mean? The condition is 30 bigger than 0. This is true, right? So I'm going to get inside the for loop and I'm going to print I. In other words, I'm going to print 30. Then I'm going to go and do update. What does this say? I equal minus equal 5. That means decrease I by 5. So I becomes 25. Once I do that, am I going to do initialization again? Obviously not. I'm going to check the condition again. This time, condition is 25 bigger than 0. This is true. So I'm going to print I. I'm going to print 25. And I'm going to check, update, decrease this one by 5 again. And now I'm going to check the condition again. So this time, condition is 20 bigger than 0. This is correct. Then I'm going to print I, 20, and I'm going to do update, decrease I by 5. This becomes 15. and the condition becomes 15 bigger than 0. This is also true. Then I will print 15. This will become 10. And this will become, since it is 10, the condition is 10 bigger than 0, which is true. I print 10. This becomes 5. Condition becomes 5 bigger than 0, which is true. I print 5. And this becomes 0. And then I come and check condition again. This time, condition is 0 bigger than 0, which is not true, and I'm done. So it will print 30, 25, 20, 15, 10, and 5. Okay? Well, I want to tell you something here. Look, here I defined int this way. That means the scope of this I is only this for loop. For example, if I have a statement here, system.out.print I. This is a compile error because it will tell you that it does not know what I is. Since I is defined right there, the scope of I is only within this left and right braces. Okay? Just to let you know. Okay. But if I did not define, let's see. Okay, I think it is, I need to wait a little bit. Okay. All right, now assume that this is not defined here, but it is defined something like this, int I. Then you can have system.out.println I, and I is 0, this will print 0. So we'll talk about those scope rules later, but there is a reason to define integer I on the top, so you can access to it anywhere in the main method. But if you don't need that, if you need I only within the for loop, you can just define int I in the for loop. This is fun stuff, okay? So plus means increase by 1. But there is a place for plus. If it is plus x, you first increase x by 1 and then you use it. But if it is x plus, you first use x, you first use x and then increase it by 1. Similarly, minus x means first decrease x and then use it. X plus x minus first use x, then decrease it. Let's be more concrete so you will understand better. Okay, here, A is 10. Okay, then I come to this line. What am I going to print? Obviously, this is going to print what? 10. No issues there. Then I go to second line. Plus A. That means first increase A, then use it. Using, what does using mean in this case? Using means printing the value of A. But before I print the value of A, I need to increase it by 1 first. Therefore, A becomes 11. Then I print it, which is 11. I hope you understand. Okay. Then I change A back to 10 here. And then I'm going to print A. This will print 10. Then I will come to this line. What does it say? First use A, then increase by 1. First use A means, don't worry about those plus, print A. So it's going to print 10, then increase A by 1. So on the screen, I'm going to see what? 10, 11, 10, 10. Okay. Let's be a little more confusing. This is just fun stuff. Okay. First, here, I have A, which is 10. Then I have B. Then I have C. But let's see. This says A++. First use A. Using A in this context means assigning A to B. So before I increase A, first I'm going to assign A to B. That means B will be 10 as well. Then A becomes 11. How about this one? This means first increase B and then use it. Using means assigning B to C. But before I do that, I have to go and increase B by 1. B is 11. Then I will assign it to C. So here, first I'm going to see 11, 11, 11. Remember, I use printf method. In printf method, I have a string right there, right there. And then person assigned D, person assigned D, person assigned D. The first person assigned D, I need to look for an integer after comma, which is A, 11. Second one, B, 11. Third one, C is 11. Now I have this here. This is very easy. What does it say? Before you use A, increase it by 1. Increase B after you use it. What does using A and B in this context? This means add A and B and assign it to C. But before you do that, first you are going to increase A by 1. So A becomes 12. So this part is 12. And before you increase B, you use it. B is 11. Before I increase, I'm going to use it. So C becomes what? 23. As soon as I assign it to C, I will go and increase B by 1. B becomes 12. So I will see 12, 12, 23. Another example, very similar to this one, just to practice. A is 10. B and C. So what does it say? First use A. That means first assign A to B. Let's go ahead and do it. I do it. B becomes 10. And then increase A by 1. Let's do it. A becomes 11. Here, first decrease C by 1 and then assign it to B. Sorry, first decrease B by 1, then assign it to C. So I'm going to go and decrease B by 1. B is 9. Then I'm going to assign it to C. Okay. So what am I going to see first? 11, 9, 9. Then I'm going to come to this. It says first decrease A by 1. I'm just going to go and decrease A by 1, 10. So this part is 10 now. And then it says first use B. I'm going to use B. B is what? 9. Using means what? Add them up, 19, and assign 19 to C. And then increase B by 1. B becomes 10. So it's going to print 10, 10, 19. I think this should be clear. Okay, here is another example for the for loop. I'm just doing a lot of examples so that you can feel comfortable. The first for loop, I'm right here. Okay, X is initialized to 0. Look, I define X here outside. Why? I'm going to access X in this for loop, in this for loop, in this for loop, so that I can define it outside those for loops so they are accessible from each one of those for loops. Okay, so what is the condition? Condition is X less than 5. So let's check the condition, 0 less than 5. This is true. Then I'm going to go and execute this statement. So I'm going to print 0. Then I will increase X by 1 right there. So X becomes 1. Condition becomes 1 less than 5. This is also true. Okay, and then it will print 1. Then increase X by 1. X becomes 2. Condition is still true because 2 is less than 5, true. It will print 2, it will print 3, it will print 4, okay? And then when after it prints 4, X will be increased by 1, X becomes 5. The condition is 5 less than 5 is not true, so it will stop. It will print 0, 1, 2, 3, 4. And then I will have an empty line, and then let's do this one. In this one, X is now what? 5. The condition is 5 bigger than 0. Is this true? Yes, it will print 5. And then decrease x by 1. That means x will become 4. It will check the condition 4, 3, 2, and finally 1. It will print 1. And then it's going to decrease x by 1. X becomes x plus 1. X becomes 0. And 0 bigger than 0, it will stop. So 5, 4, 3, 2, and 1. Then empty line. This is a little different because instead of increasing 1, we are going to increase by 2. Okay? So let's go ahead and do this. X is 0. And then 0 less than 10 is the condition. This is true. It's going to print 0. Okay? And then update x by 2. So x becomes 2. 2 is still less than 10. It will print 2. And then it will update x by 2. That means x becomes 4. 4 is still less than 10. It will go inside, print 4. And then update it by 2, x becomes 6. Okay? 6 is still less than 10. It will print 6. And update x by 2, x becomes 8. 8 is still less than 10. It will print 8 and update by 2, 10. At this point, 10 is less than 10 is incorrect, so it will print 0, 2, 4, 6, 10. Right there. Okay. So let's go and talk about break statement for the for loop. It is the same as while loop. In while loop, if you recall, if you break, you stop executing the rest of the loop and go back, and get out of the loop, okay? And this example, we have here, count 0, okay? And then condition is count less than 5. Let's see if this condition is satisfied, 0 less than or equal to 5. This is true. So I will get into it. I will check if 0 is equivalent to 3, no. I'm going to print count, okay? So what am I going to print? I'm going to print 0. Then I'm going to increase count by 1. Count becomes 1. Okay? And obviously this is still not true, and it's going to print 1. Then update by 1, this becomes 2. Sorry, what did I do? Let's see, 0 less than, for 0, I print this, increase by 1, I print 1, now it is 2, it is still less than 5, and I'm gonna print 2, and increase count by 1, and count becomes 3. 3 is still less than or equal to 5, I go in, count is equal to 3, yes, I go to break, that means I'm done. I will just get out of the loop. I will not execute this one. So it's going to show 0, 1, and 2. I hope this is clear. Continue is very similar. I mean everything is the same, but with continue, when you are at that point, we just skip the rest of the loop. What do I mean by that? Similar to previous example, count is 0. I'm not going to do all the way. Count is 0, less than 5. This is not true. It will print 0. And then it will update count by 1. This is 1. 1 is still less than or equal to 5. This is not true. It will print 1. Count becomes 2. 2 is still less than or equal to 5. And if statement is not true, it's going to print 2. Update count by 1. This becomes 3. Now, this condition is true, but also this is true, and I have continued. That means I'm going to skip this line here. Go back to the beginning of the line. That means I'm not going to print anything. And then 3 less than or equal to, before I go to the beginning first, I need to update, of course. So I repeat, count is 3, continue means skip the rest of the loop and go back to update. And I'm going to update this to 4. And then I'm going to check the condition. 4, this is true, this is not, so it's going to print 4 right there. And then it's going to go and update. And this becomes 5. Condition is still true, it will print 5. And then update to 6. But this time condition is not true and we are done. So it's going to print 0, 1, 2, 4, and 5. Well, you may have multiple, nested loops. For example, here I have a for loop. I labeled it outer loop. You can label just like this with colon. And then I have an inner loop right there. If I just say break, it's gonna break for the closest loop. But if I give a label first and I say break that label, it's going to break that for loop labeled with that label, okay? So I'm gonna have only this example right here, and then I'm gonna give you, let's check this one. Okay, so I have A1, B1 here and here. Then I assign A to 0. I initialize A to 0. This becomes 0. I'm in the outer loop. I initialize A to 0. The condition is 0 less than 3. This is true, right? Since this is true, I will get inside this loop. A is 0, and this is true. Therefore, I'm inside this. This time I will initialize B to 3. So B is 3. Is 3 bigger than or equal to 0? That is true. And I will get inside. A equal to B. Is it true? Is 0 equal to 3? No. I will decrease B by 1. So B becomes 2. I check the condition again. Is 2 bigger than or equal to 0? Yes. I will get in. But is 0 equal to B? No. I will decrease B by 1 again. Is 1 bigger than or equal to 0? Yes. But A is 0, B is 1. This is not true. I will decrease B by 1 again. This is 0. Now, is 0 bigger than or equal to 0? Yes. I get inside. A is 0, B is 0. Is 0 equivalent to 0? Yes. It says break outer. That means I'm going to get out of this loop right here, all the way here, and it will print A is 0, B is 0. I'm not gonna do this example, and this one breaks the outer loop, this one breaks the inner loop. This is gonna be a little longer to trace, so I'm gonna assign it as a fun homework for you to do it by yourself, and the output will be 3 and 1, okay? If you cannot, let me know. Do-while repetition structure. Do-while is also an important structure, okay? The difference between do-while and while. Do-while is executed at least once. You execute it at least once, then you check the condition. You execute once and check the condition. In the while loop, you first check the condition, and depending on the condition, you may execute or not, okay? Here, condition will be again Boolean. We have parentheses, but don't, the parentheses, don't forget those parentheses. Also, don't forget the semicolon, okay? And let's see an example here. Let's look at this. X is 20, okay? And then I have do. That means before I check any condition, I'm gonna go and execute those two statements. It will say inside do while, and it's going to print what? X, which is, it's gonna print 20. It will say inside do blah, blah, and then 20. Then it will check the condition. Is 20 less than 15? No, that's it. I'm done. So I will see only inside do while and 20, okay? However, If we do the same thing with while loop, let's see the difference. X is 20. Now it says 20 less than 15. Is this condition true? No. So it will not even execute once. So you're not going to see anything here. Okay, let's check this example. I have X 20. Okay. Then I have do while, that means I will get inside without checking anything, and I will decrease X by 4. So X becomes what? 16 here. And that's going to go ahead and print it. So on the screen, I will see 16. Then I will check the condition. Is 16 bigger than 0? Yes. I go back. I decrease X again by 4. So this becomes 12. And then I'm going to print it. And then I will check the condition. 12 is bigger than 0. I go back and do this again. So X becomes 8. And I'm going to print 8. Check the condition. 8 is still bigger than 0. Go back to the beginning. X becomes 4. And I'm going to print 4. This is 4, and I'm going to print 4. Check the condition. 4 is still bigger than 0. Go here, decrease it by 4, and then this becomes 0, and I'm going to print 0. Then go and check the condition. Is 0 bigger than 0? No, so I'm done. So you're going to see 16, 12, 8, and also 4 and 0. Switch multiple selection structure. This is useful. I don't use it too often, but it is useful. And switch statement takes an integral expression or a string. Let's go to the next one so you're going to understand better. Let's say that you have a variable x. X can be any integer, any integral type like int, byte, short, character, or it can be string. Okay. Then, depending on different cases, you will execute statement. But if you forget a break, it will keep going. And I'll explain what I mean by some examples. Let's look at this. It's a pretty simple example. Don't get intimidated. I have my main class, and here is the starting point right there. I create a scanner object, and I ask the user to enter a number. Okay. Let's assume that the user enters, I'm making it up, let's say the user enters 2. Then day is 2, okay? Then I will say, what is it? Is it case 1? No. Is it case 2? Yes, right? So it's going to print Tuesday. Do I have a break? Yes, that's it. It will only print Tuesday. If I enter 5, it's going to print Friday, because I have break. If I enter 3, it's going to print what? Wednesday. Okay. I think in this example, for example, I say 3, it prints Wednesday. I say 6, it prints what? Saturday. How about if I put 32? If it is not any one of those cases, it will go to the default and it will say, it will print not a valid day. Okay. How about if I don't have break? For example, here I don't have break here. So in this case, if I enter 1, it will print Monday. That's it. If I enter 2, it will print Tuesday because I have break. But if I enter 3, it will print Wednesday, Thursday, Friday, Saturday until it sees a break. If I enter 4, it will print Thursday, Friday, Saturday. If I enter 5, it will say Friday, Saturday. If I enter 6, only Saturday because I have break. If I enter 7, only Sunday. If I enter 100, it's going to go and print default, not a valid day. I guess in this example, I have 2, Tuesday, because I have break. I enter 3, Wednesday, Thursday, Friday, Saturday. Okay. Well, switch statement can also have a string. In the early versions of Java, this was not possible. So this is an improvement. So let's see what do we do here. We create a scanner object. We say enter your last name. Okay, let's show this one here. It says enter your last name. Assume that I type segment and press enter. So name is going to be what? I use next line method of scanner class via scan object. That means name is going to be here. Name is gonna be a string, which is segment. Okay, here I type segment, so name will be segment. I will switch to name. That means, okay, focus on name, which is, in this case, segment. Is it segment? Yes. Then it will print Dr. Ali segment. And since I have break, it will break. If I type Rogers, do I have this case Rogers? Yes, right? It will print Dr. Tamara Rogers. If I type Chen, this is just, I don't know where it's coming, Chen, it's gonna print Dr. Wei Chen. But if type something which is not segment Rogers or Chen, let's say dot, then it will go to default and it will say another professor. Logical operators. So we are going to talk about logical operators. We are going to talk about and, or, we're not going to talk about not, but there are two ands and two ors. But first, do we know what and or are? So let's first discuss the meaning of that. I mean, this is a simple discrete math issue. If you have taken discrete math class, you must know those. But think about two statements, okay? Two statements. One is, let's say, it is sunny, okay? All right. And another one is, it is Sunday, okay? And I say, I'm gonna go swimming if it is sunny and if it is Sunday. So if it is sunny and if it is Sunday, I will go to swimming. In order for me to go to swimming, it must satisfy both conditions. It must be sunny and it must be Sunday. If it is sunny but not Sunday, I don't go to swimming. If it is not sunny and it is Sunday, I still don't go to swimming. If it is not sunny nor it is Sunday, I definitely don't go to swimming. So basically, if you have two statements, A and B, okay, A and B, let's say false, false, true, true, false, true, false, true. If it is not sunny and if it is not Sunday, I am definitely not going to swimming, right? If it is not sunny, but if it is Sunday, I still don't go to swimming. If it is sunny, but if it is not Sunday, I don't go to swimming. If it is sunny and if it is Sunday, I go to what? Swimming. In other words, with and, in order for the compound statement to be true, both of the statements must be true. Otherwise, compound statement will be what? False. However, or, if I say, if it is sunny or it is Sunday, I go to swimming. It is enough that only one condition is satisfied. For example, if it is sunny but not Sunday, I will still go to swimming because I said or. Okay, in this case, A, B, and then let's say A or B, false, false, true, true, false, true, false, true. If it is not sunny, let's say that it is not sunny and it is not Sunday. Do I go to swimming? Definitely not, because I said If it is sunny or Sunday, at least one of them must be true for me to go to swimming. If it is not sunny, but if it is Sunday, do I go to swimming? Yes. If it is sunny, but if it is not Sunday, I still go to swimming. If both of them are true, I definitely go to swimming. So for or, look at this. If the first statement is true, no matter what the second statement is, I don't care. It is always what? Composite statement is always true. So if the first statement is true, no matter what the second one is, the composite statement is definitely true. But here, if the first statement is false, no matter what the second is, I don't care about them. The composite statement is always false. So for and, if the first one is false, you don't need to check the second one. You know that the composite statement will be what? False. In or, if the first statement is true, you don't need to check the second statement because you know that the composite statement will be what? True. So the difference between this double ampersand and single, if it is double, as soon as the falsity or truth value is known, you stop. For example, if the first statement is false, you know that there's no need to execute the second one because you know that the composite statement is false. So this is exactly what you do with double ampersand. But if you have single ampersand, I know if the first one is false, no matter what the second one is true or false, I know it is false, but I still execute the second one. So if you have single, you still execute the second one. For example, logical or, if you have double pipes, I know that if the first one is true, no matter what the second is, if the first one is true, no matter what the second is, I know the composite statement is true. So I just don't execute the second one. However, if it is single ampersand, I know if the first one is true, no matter what the second one is still true, but I still go and execute the second one. That's the difference. And I will show you with an example. So this repeats the same thing. An expression that contains double ampersand or double pipes is evaluated only until truth or falsity is known. However, if you have an expression that contains single ampersand or single pipe, you have to execute all the operands. Let's see with this example here. Okay, first of all, I have double, right? Since I have double ampersand, that means that's and. In and operation, if the first one is false, no matter what the second one is, the composite statement is false. And since this is double, I will evaluate until I know the truth or falsity, okay? So let's see. Let's start with this right here. X is 10, right? X is 10. And Y is 20. Okay, so now here, X is equal to 5. This is false, is that right? This is false. 10 is not equal to 5. Since this is double ampersand, I will not go and execute the second statement because I know if the first one is false, no matter what the second one is, the composite statement is false. That means I am not going to go inside the if block. Then it's going to print step 2, and it's going to print y is equal to 20, okay? It's going to print step 2. All right. So then I assign x 10, y 20, which is already the case. This time, this is true, okay? So if the first one is true, is it enough to conclude if the composite statement is true? No, we cannot do that. If the first one is true, we need to check the second one. If the second one is also true, the composite statement is true. Therefore, I'm going to go and execute this one. So it is y plus plus, right? Plus plus comes after y. That means first I'm going to use y, then increase by 1. Using y means comparing y to 20. So I'm going to compare y to 20 first. Y was 20. Is 20 equal to 20? This is also true. And I will increase y by 1. Y becomes 21. Since this is true and true, composite statement will be true. That means I'm going to get inside the for loop right here. So it's going to print step 3 and y is equal to 21. You see that? And do you see the difference? I mean, yeah. So if I don't execute the second statement, I did not increase y here. But when I execute the second statement, I did increase y by 1. So let's see. It's going to print that. Also, I'm going to show you that, done. Oops. Let's see if I can go back. Yeah, okay. I just want to go back so that you can see I cleared it. And the green one is executed, the red one is not executed. Similarly, so the first, so the green statements are executed, the red one is not executed in this example. How about this one? Now, the difference is that I have single ampersand. That means whether the first one is true or false, I will always execute the second one, right? So I'm going to go here. This is false because 10 is not equal to 5. But since this is single, I will still go and execute the second one. Executing second one means first compare y to 20, which is true, and then increase y by 1. So x was 10, y was 20. Now I will increase y by 1 and y becomes 21. False and true is false. So I'm not going to get into this. Here it will print step 2 and y is equal to 21. Then I will go to this, x is 10, y 20. That means I'm going to change back this to 20. Okay. And then x equal 10. This is true. And this is single, so I will definitely go and check this one. This is also true. And then increase y by 1. Y becomes 21. True and true. I go inside. It will print step 3. And then y is equal to 21. Okay. So all those statements will be what? Executed for us. Okay, so now the same thing, but this time I have or double pipes. That means if the first statement is true, there is no need to execute the second one, because no matter what the second one is, the composite statement is what? True. So I'm going to go here. This is false. Again, x is 10, y is 20. I'm going to improve my handwriting definitely. Maybe I should put my iPad on the flat surface, but for now, this is what we have. So this is false. Well, if it is or, if the first one is false, that's not enough to conclude for the composite. We have to look for the second one. So the second one is true because y is equal to 20. First I compare and then I will increase y by 1. False or true is true. That means I'm going to get inside this. It's going to print step 1 and y is equal to 21. And then it's going to print step 2, y is equal to 21. Then it will change y here. It's going to change y back to what? 20. So this is 20. Now, this one is true. Well, this is or. If the first one is true, is there any need to go to second one? No, because true and anything, true or anything is true. So I'm going to get inside. I'm not going to execute this one. It's going to print step 3. And then y is equal to 20. Okay. So I execute both of those statements, but I only execute the first one in the second if. Similarly, I guess you get the idea. Now I have single. That means no matter what the first one is, I will execute both of them. So this is going to be false, but I still, false or not, doesn't matter. I execute this one. This is true. X was 10, Y was 20. So false or true is true. I go in, it says step 1, and Y is equal to 20. Step 2, and Y is equal to 20. And then, of course, here Y is changed to 21, sorry, because I executed this. This is 21, this is 21. Now Y is changed back to 20. And this is what? True. Even though this is true, even though I didn't need to execute since this is single ampersand, I'm going to go and do this. This is true. And then I'm going to increase Y by 1, 21. True or true is true. I get into step 3 and Y is equal to 21. Okay. So that means I execute all those statements. I hope this was clear. So I'm going to stop here talking about control structures. Okay, let's see. I'm gonna stop talking about control structures. Maybe I should stop sharing here. But now, since we are done with the control structures, I still want to do a little bit more so that you don't forget how to write Java programs, how easy it is, and so on. So I'm going to write a simple Java program using command prompt or terminal or a text editor like Notepad or TextEdit. Okay, so let me go ahead and get started. Okay, so here is my screen. In order to write our Java program, it's pretty simple, okay? So what we need to do is first we need to bring up our text editor. I'm using Mac, so I'm gonna bring TextEdit. If you are using Windows, you are supposed to bring what? Notepad, okay? So that's my text editor. Okay, then I need to bring up my terminal. I'm gonna bring my terminal app. If you are under Windows, you are supposed to bring what? Command prompt app, okay? All right, I'm gonna make, oops. And we wanna be organized. Previously, we opened a folder called learning, right? This was our folder. I'm gonna clean everything in this folder. Okay, so this is the folder that I'm gonna work. Now, my graphical user interface for the operating system, this is my desktop, this is my learning folder. Learning folder is free, is totally empty. But look at here, do you see this tilde? Tilde means I am in the user folder. You know, my username is Segman, so I'm under that main folder that every user has. So if I say ls here, listing, it tells me that I have those subfolders. For example, desktop is a subfolder under the main user folder. And my learning folder is under desktop. So that means I first need to navigate to my desktop. Now, you see here, it used to be tilde, but now it is what? Desktop. That means I'm in desktop. Now, if I say ls, it's going to show me that I have the learning subfolder. I can go and navigate to learning subfolder with change directory. Let's clear this. ls, as you see right now, both from graphical user interface, I am under learning folder, and also from command line interface, I am under learning folder as well. Now I'm going to go and write my program. Okay, so the first thing is commands. We should give some commands. Let's say writing example together. So this is our program together. So I'm gonna go and add public class, give a name, let's say test. Of course, you don't have to give test, okay? And everything will be what? Inside this class file, public class test. And then I have to have what? Public static void main string array, okay? Right here. So let's save this. I'm gonna save it under desktop, learning folder. So the name of my class is test. I am required to use what? Test.java. Test with capital T, my file name must start with capital T, okay? Here you go. So, boom, I have what? Test.java here. And now if I say ls, test.java also here. So these two, this is command line interface, this is graphical interface. They're almost the same. I can navigate in the folder structure. But command line interface is a more powerful tool. And as a computer science student, you will have to use it. And it's an opportunity for you in this class that you get familiar with that interface. So now, in order to compile my program, I type javac space test.java. If everything is okay, it's just gonna compile, okay? Well, since the program doesn't do anything, when I try to run it with Java test, it will just be like this, okay? And, okay, let's add system.out.println, okay, hello. Okay, I know I explain things sometimes multiple times just to emphasize, okay? Let's look at this. Now I'm just gonna go with up and down arrows, Java test. Okay, so there's an error. And it's a good thing with this text editor because when you make errors, there is no auto correction for you. So no one is gonna correct. So you have to fix it by yourself. Obviously, I have a spelling error here. I go with right, get the arrow again, compiles, and then I run, it says hello. So a couple of things. First of all, we talked about this main method, right? Main method is a special method. When you run Java, Java will go and look for an entry point. And main method is the entry point. If you have the main method, it will go and run the first line in the main method. But it needs to be the main method, as I expressed before. For example, assume that I go and change this string array to an integer array. Well, it will still compile because syntax is correct. So I have a method main, and it is defined like that, but it is not the main method that Java is looking for. So when you try to compile, when you try to run, you are gonna get an error because it will say that, please define the main method as this. You see that? So it's looking for a string array. So therefore, it is a method, but it's not the main method Java can automatically run. So you have to change this one back to what? String, okay? All right, so I told you before, you can switch the places public and static. For example, you can put public here and then compile and run. It will be fine, okay? Or you can get that square bracket here instead of here. When we discuss arrays, you're gonna understand better. You can compile and you can run, no problem, okay? So let's write a meaningful program. Let's write a program. Let's say that it is going to ask your name, and it's going to ask your score, and then it's going to print your score and your name somehow back to you, okay? So I'm going to ask something from the user, from the command prompt or terminal. Therefore, I need to use scanner class. In order to do that, I need to import scanner class, java.util.scanner, okay? By the way, if I go and put star here, Well, this means import all the classes from the utilities package. But since we are going to use only scanner class, it doesn't make any sense to import all the classes unnecessarily. So I'm just going to go and import scanner class only. Okay, if I have scanner class, I need to create a scanner object. Let's say scanner TSU is equal to new scanner. Of course, we should give meaningful names. So I'm just trying to show you that I can give any name, but I really want to give meaningful name, like maybe OBJ, or let's say input. How about that? Because I'm going to ask input from the user. I'm going to ask two things, right? I'm going to ask a name, which is a string, and then I'm going to ask score, integer, or let's make it double. Okay. Again, as common practice, I define my variables on the top of the method before defining or before creating an object of scale. The order doesn't matter, but it is the way that I like, and this is the way to make us more organized. Okay. Now I'm going to ask system.out.print. Okay. I will say enter your score. Okay. I'm asking to enter the score. And then since that's double, for example, 85.5, I'm going to read it into score, but I am going to read it via which method? Next double method of what? Scanner class. How do I know next double is method of scanner class? Because I'm calling it via input, and input is a scanner object. So it's going to read the score, and then I will say system.out.print enter your name. Of course, the order can be first name then score, and then I will say name is equal to this time input.next. I'm going to read it with this. Then I'm going to say system.out. Let's say printf method this time. Okay, your hello person is signed S. Okay. Your score is person is signed F. Let's see if we are gonna be able to recognize those. Person is signed F. And then I will say name, and then I will say score. Okay, so it's gonna replace person S with name, person F with score. But of course, I'm going to test if you remember the things that we discussed before with person is sign F. But let's go ahead and compile this program, save it. If there are no errors, let's see if there are errors. No errors, compile and run it. Enter your score, 86.9. Enter your name, Ali. Hello, Ali, your score is 86.9000. I don't like this. Remember, the default was 6 digits. But if I go in here, for example, put, let's say, after that, I want to have a total of 8, but after that, I want to have only what? 2 digits. So here, your score, 87, let's say that. Your name is John. Okay, now it says 87.88. You see, because of this 2, after that I have this. But because of 8, it's gonna put 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. While after this, there should be 3 characters right there. Okay. Well, you don't need to do that, and I guess you can change it. but also you can make it left aligned with this dash. Okay. All right, so this is just to remember. Of course, so far we use only a text editor, and yeah, well, text editor is good, so you see your mistakes, and I want to use it for maybe another week or so. But I also had a video that shows you how to install Visual Studio Code. Visual Studio Code is a source code editor developed by Microsoft, and it's platform independent. It's pretty good. I really like it. And at one point, you should switch to using it. In fact, let me show you how you can use Visual Studio Code. Please watch the video on it because I already show you how to install. I assume that you have it installed. Then run this. You can get rid of welcome. You go here. Okay, so we work in the learning folder, right? So I'm gonna go and open that learning folder from here. So Visual Studio Code on the left-hand side is gonna show the folder that I'm working in. Let's get rid of this, let's get rid of this. So it shows the learning folder. In the learning folder, remember, I have two files, test.class, test.java. Let's delete test.class so that you can see it will also be deleted what? Right here, okay? And then here, if I double click, it's gonna bring my Java code here. As you see, this is pretty nice. I mean, it's color coded and I have everything there. And then I have my terminal right here. I mean, if you don't have your terminal, you should just say, for example, let me close the terminal here. If you don't see your terminal, go here and say new terminal. It will bring the terminal and it will automatically navigate to what? To the learning folder for you. Because I'm working from the learning folder. You don't have to do ls, cd, and things like that. It's very nice. Now I have my folder on the left. I have my code editor here, which is pretty nice. And then I have what? My terminal here. I can go ahead and run it by picking this one, like run. And it will compile it and it will run it. You can say 65 point this and your name, John, and it will do, but I don't like this. I don't want you to run here from there, okay? All you need to do is, because this is a terminal, you can use the way that we used before. You can write Java C and then test.java. It will compile it for you. You can say Java, you see, as soon as it compiled, it created what? Class file for you right there. And then Java test, and then it's gonna run. Okay, so you don't have to, I mean, I really like to use the terminal. So to sum up, Visual Studio Code is a pretty nice software, code editor. So you put your folder here, your code is there, and then your terminal is here. And I believe you can also change settings. For example, let's see if I can change the font. If I go to text editor, here you go, font size, let's make it, for example, 16. I'm gonna make it 16 so that, you know, we can see better, okay? So if you wanna write your code from scratch, and it is pretty nice, you say import. As soon as you say import, java.util, well, it will show you all possible classes here. You don't have to memorize. For example, scanner is one of them, okay? Oops. And then when you say public class test, left brace, it automatically opens right brace, and it automatically indents one character, one space, one tab, public, static, void, main, string, args, okay? And it will automatically put left and right. When you put left brace, right brace, and then here, you can say system.out out.println, let's say hello. When you have double quotes, it automatically closes it, and assume that you forget the semicolon at the end. It gives you an error message. Hey, you need semicolon at the end. It's pretty straight. And there is a warning here. It says you did not, well, let's see. Yeah, we didn't create any objects of it. So it says maybe you should create an object like this, okay? So that's it. I mean, you can compile again and you can run, okay? So what did we learn today? We learned the control structures. They are pretty straightforward. We have if, else, while, for loop, switch. We learned about increment, decrement, plus, plus. So whether you increase it before you use or after you use. We talked about logical and, logical or, Boolean logical and, Boolean logical or, and those concepts. You have to practice a lot. This is important. If you feel comfortable, you can even start with Visual Studio Code. And I hope you enjoyed it, and I'll be seeing you in the next video lecture.